Okay, hello guys. So thank you for attending my session. We're going to be talking about cloud, and specifically on cloud, I'll be comparing Cloud SQL, that is from GCP, versus AWS RDS versus Azure, right? We're going to be comparing all the features that they have and they support. And at the end, or I mean, not at the end, starting, we'll try and keep a scorecard. So we're going to be scoring each one of them after we discuss a feature. And at the end, we'll have the final score. So we'll be able to figure out who wins the battle. Sounds interesting, right? Let's get started. So a little bit about me. I'm a project engineer working at Pythian. I do a lot of stuff because I just can't make my mind on what to do. So I've worked as a SQL Server administrator, MySQL administrator. I'm currently working as a cloud architect and a DevOps engineer in the cloud itself, right? I have an addiction. I can't stop getting certified. So, I mean, if there is a certification out there, I have to get it, especially if it's on cloud. So it's a long list. I'll not bore you with the certifications I've done because there are so many and I couldn't put all of those on the list. And this addiction is actually supported by my company, Pythian. They fund my addiction and I keep doing the trainings and going on with these things. So this is what we're going to discuss. Amazon RDS versus GCP Cloud SQL versus Azure Database Services. A lot of people ask me, does Azure support MySQL and PostgreSQL? Because they are like SQL Server, so they have that product and they have been supporting SQL Server only for a very long period of time. But now they do support MySQL and PostgreSQL as well. And it is generally available. So we're going to keep all of those things in mind, and we're going to discuss all of that as well in this presentation. Before we go into discussing the RDBMS, we will discuss what are different data storage services that are available, what they are all about, and then we'll also see on what are the different alternatives, or at least what are the names that each vendor supports. So you'll have a little bit of distinguish between all of those. Right, so this is not an exhaustive list of all the data storage services that are available, but I've tried to put all of them together. So there is block storage, which is your hard disks, your SSDs, especially where you can install a file system. You can store your files like your laptops, your servers, where you have hard disks and SSDs, right? So that's like block storage in itself. Object store is where you store blobs. For example, everyone literally knows about S3, AWS S3, Azure blob storage, and GCS. If you haven't heard about it, we'll discuss that in the next slide, right? So it's like taking all the blobs, which could be your images, could be your movies, could be anything, an Excel file, a file that you want, a PDF, whatever, any unstructured data that you want to put on goes into object store. It does not have any file system. It's just like a key value pair where you simply store your files. Then we have RDBMS, which is rows and columns. You perform selects, you perform inserts, updates, deletes, and we are all aware of what that is. Then we have NoSQL. So problem with RDBMS is that it is very schema restricted and it doesn't scale well. You can't horizontally scale RDBMS for like both reads and writes, right? So that's where NoSQL comes in, where it is schemaless and it scales really well. Both scales up very well and scales down very well as well. Then we have big data, which is for both structured and unstructured data, and you can store all of your data and perform analysis and insights on top of that data. Then we have warehousing, which is RDBMS, but it really takes data from a lot of heterogeneous sources, extracts it, transforms it, put it into a database, and then you can use it for reporting and analytics. So this slide is the most debatable slide that I've ever put together, because this is a flow diagram that I tried to put together on how to pick a service, how to pick a data storage service. Some people might agree, most of them won't. And if you don't agree, talk to me about it, and I'll make you agree on how and why this is correct. And if I don't, then I'll change it, right? So going with the flow diagram, you can start with that. What type of data do you have? Is it like a structured data or is unstructured data? If it's unstructured data, go with an object store. You have to store all of your data like on a S3, on a GCS, or blob storage on Azure, right? Then do you need relational capability? Is it your infrastructure or your database needs the way you're going to storing your data? Is it like rows, columns, and tables? Look for a relational database service, right? Then do you need analytics from there? Do you need to perform warehousing? Look for a data warehouse solution. If you don't need analytics and reporting, we move on. Is the size a constraint for you? Because RDBMS, it's beyond TBs, it does not scale very well, like not even vertically and not even horizontally. You'll have issues maintaining very large databases. Now, that is also debatable because some people will say that we have had this, but you already know that how difficult it is to manage very large databases, right? Maximum connections. Do you need more than 4,000 concurrent connections? If you need them, then okay, we'll look at some other solution. But if you don't need any more than 4,000 concurrent connections and you don't need scalability and strongly consistent data, then we can move on. If you need scalability and strongly consistent data, we can move on. Otherwise, there is only one service that I can think of, or I know any vendor has implemented so far, which scales across the world, provides you high number of concurrent connections, that is Spanner. That is a service that is only provided by Google. It's pretty amazing because you can have a database, a RDBMS database, which scales horizontally across the whole world. So you can have a node in the US and you can have a node in the European region, and both doing reads and write simultaneously. And it's pretty amazing how they do it because Google's infrastructure is amazing, especially their network. They have a dark fiber network that spans across the world. I mean, to make it more amazing, think about this. You are sitting in Australia, you have a server in Australia, and you RDP to a server, not RDP, you ping a server in the US as if they were in the same network without having a need of a VPN. You are talking privately over that network. You can only do that on Google so far. I mean, that's all I know. I don't know any other vendor being able to achieve anything like that. And that's what Spanner is built on top of. If you don't have any specific OS requirements, you don't have any configuration requirements that you want to stick to, you can go with the RDBMS DBaaS solution that is offered by all three vendors, right? If you have any specific requirements of an OS, you need more management, you need more configuration, which is not supported by DBaaS solutions, look for an IaaS solution. Install a VM and put your database on top of that. That's also a solution that is available with all the vendors, right? Now, if you don't need relational capability, then we can talk about NoSQL or big data. And this is where my knowledge of big data and NoSQL is limited, right? So this part is mostly debatable because I might not have put all of these details together perfectly, right? But at least for the NoSQL, that's correct. NoSQL supports eventual consistency, right? It scales very well, right? You can store TBs of data and it's schemaless. So if you have those needs, use a NoSQL solution. And if you need like very high volumes of writes, you need low latency, high bandwidth is a big requirement for you for storing your data, look for big data capabilities. That's where you can store your data if you have that requirement, right? If you don't agree with any of these, I'm going to be around, right? So talk to me about it. You'll have my email. Send me an email and say that your slides was rubbish. We don't agree to it, and we want to change it, and I'll make that change if I agree to it. Right. So what are different data storage services that are available on the cloud? Block storage, there is EBS on AWS, and based on all the services that's out there, there is persistent SSDs, hard disk and disk on GCP, there is Azure Managed Disk on Azure. What I really like about AWS EBS is the ability that you get to be able to manage cost and at the same time to be able to manage the IOPS as well. They give you different, different types of storage. There's GP2, there is PyOps, and there are cold SSDs and other disks as well, which goes cheap, and you can manage the number of IOPS, which is like pretty limited with GCP and Microsoft Azure because they provide you the disk, the highest the size of the disk, the more IOPS you get. But with AWS, you can actually put a constraint on how many number of IOPS you want, which is probably one of the best features that I like about EBS. Object Store is simple storage service on AWS, Google Cloud Storage on GCP, and Microsoft Azure has blob storage. All of these support similar kind of features, right? And whatever you choose, the cost is also similar. The availability and durability of all these object stores is pretty much the same, right? I mean, AWS does say that they have 99.99, like 11 nines durability, while GCP only claims to have like 99.99% durability. But based on my thought, how would you know, how would a person distinguish between a 11 nines durability versus a 4 nines durability? I mean, you can't really match that number. There is not much of a difference, right? So based on my thought, all of those vendors provide the same solution, and you can use any one of these provided whichever vendor you like to use, right? Then this is what we're going to talk about. RDS versus Cloud SQL, that is with GCP and Microsoft Azure's SQL Azure and database services. Database services, Azure Database Services is something which supports MySQL and PostgreSQL as well, right? Spanner is also there on the list, but except for the fact that Spanner is very costly to use, it literally beats each of the service hands down, right? So we're not going to be discussing Spanner as of now because my knowledge of Spanner is limited. It's been available like for a year to general public. I mean, it was literally made generally available 4 or 5 months ago, right? So I'm not going to use or discuss Spanner in this particular comparison, right? But if you are interested, it is one of the most amazing services that I've ever came across, right? And it's fully managed. So if you are interested, do read about it. NoSQL, there is DynamoDB, there is Datastore and Cosmos DB on Microsoft Azure. Data Warehouse, there is Redshift, BigQuery, and Azure SQL Data Warehouse. And for big data, there is Amazon EMR, which is Elastic MapReduce, Bigtable on GCP, and HD Insight and Data Lake on Microsoft Azure. A mention over here for BigQuery is one of its services that allows you to store petabytes of data and perform analytics on top of that using SQL-like code in literally seconds. I mean, you can have huge amount of data sets stored in BigQuery, and it performs the analysis like the speed is tremendous, right? And I loved using BigQuery. It's pretty amazing what you can do at such little cost. I could not find, I mean, having BigQuery there compared to Redshift and SQL Data Warehouse, it's like an insult of BigQuery, right? Because it's really cheap and it's awesome, right? If you're interested, read about it. I'd probably do another version of a big data and data warehousing in some other conference, but for now, we're going to stick to RDBMS capabilities, right? So which vendor do I endorse? So with Google, the machine learning capabilities and big data capabilities of Google are nowhere to match. I've tried Amazon and I've tried Google, their machine learning and big data capabilities. Google stands out. I mean, for me, it's like a decade ahead of what Amazon is doing at this point of time, right? Everyone is literally talking about why Google is amazing, right? And we are like top 5% partners of Google right now, right? So, I mean, we endorse Google a lot, right? everyone is talking about why Google is awesome because of its infrastructure and its big data and machine learning capabilities. No one talks about what is the problem with Google. The problem with GCP is their infrastructure is awesome. If you start using GCP because of their infrastructure, if you decide to move out, you'll have nowhere to go because you won't be able to build such an infrastructure. I mean, think about this. Having to lay down wires across the whole globe to have an internal private network of your own, it's insane. You won't be able to do it, right? I mean, if you have the capital, of course, you will be able to do it, but let's be realistic over here, right? So with Google, the only problem that I find out is that if someone is using Google extensively, and if I have to move them out of Google, it's literally impossible for me because the kind of infrastructure they provide, there is no one else who can actually support that. With RDBMS itself, AWS literally stands out, right? Because they have so much support, so many features that no other vendor can support, at least at this point of time. And with Microsoft, if you are going to use SQL Server, then I would highly recommend that you stick to SQL Azure because it's their product and they are doing a better job at maintaining it and providing you least amount of cost when compared to other vendors. And these are like not just vague statements. I'll support them going forward, right? How do we decide which vendor wins, right? So what I've done is I've put together a scorecard and I'll discuss the features, and as I go on, I'll put in a score where one feature or one service stands out over the another, right? So the first thing that I'm going to compare is comparing the number of engines that are supported by each of the vendor. Right, so AWS supports literally everything. I mean, it supports Oracle, it supports SQL Server, it supports, and these are managed services, by the way, like it's all managed. It's a platform as a service solution. It also has its own proprietary Amazon Aurora, right, which is an enterprise class solution, which is an answer to Oracle's Oracle and Microsoft's SQL Server, right? So having it on the list and crossing down GCP and Azure database services is not entirely correct because it's their product, right? So I don't know if GCP or Azure database services will ever support it because it's Amazon proprietary product, right? They all support MySQL. Only Amazon RDS currently support MariaDB. Now, no of the other vendors supports MariaDB, right? This could change in the future, by the way, right? So, I mean, because cloud is something that is rapidly growing, so this could change anytime soon. Then they all support PostgreSQL as well. A little bit of mention about Amazon Aurora. It's a MySQL and a PostgreSQL compatible database. It's an enterprise class solution provided by Amazon. And we have had some benchmarks that we have tried out, and it kind of supports Amazon's statement that it is 5x faster, provides better performance over MySQL, and 3 times better performance than PostgreSQL running on the same hardware, right? But it does have an extra cost because you'll have to pay for its license, right? Which takes us to the next topic, the pricing. How much is going to cost? How much it is going to cost? First of all, what are different metrics that decide what price you're going to pay when you are picking up a cloud vendor? There are lots of factors. The type of the instance, which is how much resources you are going to have on that instance. It could be like a memory optimized instance. It could be a CPU optimized instance. And based on those resources, you will get the good or the better performance on that particular vendor, right? How are you purchasing it? Are you reserving an instance? Because on a production instance, you don't use it for like 1 hour or 2 hours, right? So you use it probably for a year, 3 years, and that's probably what your plan is, right? So that's where you can actually go ahead and reserve it, where you'll get some discounts on top of it. Data storage and I/O operations. So how much data are you going to be storing? How big your database is, right? So that is also charged. Backup storage. You will be taking backups for sure, right? It could be an automated backup, it could be a manual backup. You'll be taking those backups to make sure that you can revert back to an old state, or if there is something, if something goes wrong, you can restore back that database. So that is also charged. Data transfers. So what are data transfers? You can have a regional or a multi-zone deployment where you can have one instance in another data center and another instance in another data center replicated to each other for providing maybe disaster recovery or high availability, right? So that data transfer is also charged by all the vendors. High availability configuration is also charged, which is because you'll be spinning up a new instance in probably another region or another availability zone or another data center within the same region, right? So that is also charged. Read replicas is also another instance which you will be deploying and is also charged. And it's basically the same of what you'll be paying for the actual instance that you have provisioned. And then licensing. This does not apply to all the databases, but if you're using Oracle or SQL Server, you'll have to pay for the license, right? And licenses comes in, there's like bring your own license and license included. So let's say if you already have a license that you have had on premise and you want to move it or use it on cloud, you can use it. But currently it's only supported with Amazon RDS Oracle. It is not supported with any other vendor. Or even if you have a SQL Server license on premise and you want to use it with SQL Azure, it's not supported at this point of time. With managed instance, they saying that they'll support it at least for the Windows instances, but that's not generally available at this point of time at least, right? REST licenses are pretty much free. Right, so this is a table that I tried to put together on how much it's gonna cost for having a production instance on each of the vendor, right? So AWS RDS, you'll see that AWS is discussed twice over here. There is a reason for that, because I discussed earlier that if you are using a production instance, you'll not deploy it for like a year, like an hour or 1 day. You'll probably try and use it for a year or maybe more than a year, right? So you can actually reserve it. If you decide to reserve it, the cost goes down drastically. You get a discount, which is like from 15% to up to 70%, right? And you can check out the documentation for that. Each different service or each different service that you're going to be deploying will have a different cost associated with it, and you'll get a different discount. And again, this is 1 year reservation. If you decide to reserve it for 3 years, the discount also goes higher, right? And I've compared exactly the same number of resources, the same tier for all the vendors over here, right? So to compare the cost. Then we have SQL Azure, which is for using MySQL, it's a little costlier. And then we have Cloud SQL, which does not provide any reservation, by the way, but it's cheaper if you go with on-demand. Another mention over here is that I have also included the cost of configuring high availability in all of these, right? So which is like a separate instance. We're not paying for like single instance per month. We'll be paying for 2 separate instances, because the high availability instance is also charged as the cost of the actual individual read and write instance. A mention about GCP over here is that it offers read replica as well on the high availability node. So the node that you have in the another availability zone or data center, which was going to be a passive node, you can use it for reads, which is not something which is available with the other vendors. Of course, you can have read replicas, which is also supported with GCP, but their passive node will not allow you to read from it, which GCP does provide. So if you do the math, then the cost decreases for GCP, because then if you need a read replica for those, you'll have to deploy a third instance and get high availability, right? But the cost will again increase. So GCP kind of scores over there. And another important aspect of GCP is their sustained use discount. Once you have decided that you're going to be sticking into GCP and you're going to be using some service for a longer period of time, over a month, they start offering you discounts. It could be a discount, that could be like 10%, 15% based on how much your usage is, up to, I don't remember the exact count, but up to like 55%, right? So they offer you discounts automatically. You don't have to do anything. You don't have to configure it. They automatically go ahead and offer the discounts. So in the actual cost for this on demand was plus 30%, but GCP will directly offer it to you. And it's available for everyone. Now, if you were going to use, where the cost changes is, if you were going to use SQL Server Enterprise, right, the cost is 4 times more on AWS RDS versus on Microsoft SQL Azure. Even with reservation, even if you decide to reserve it, it's 3 to 4 times costlier, right? Which is why I have put in Amazon Aurora over here to make the competition a little better, because AWS is not endorsing SQL Server. They want Aurora to be their enterprise class solution, right? So which is why I've put in Aurora, which is cheaper than using SQL Server. So if you reserve it, AWS is the cheapest vendor. If you don't want to reserve it, if you want to go ahead and use on-demand pricing, which there could be a reason for that because you're not sure about resourcing. Because another aspect of reserving an instance is that once you assign the resources, you are stuck with it. You cannot go back or change it, right? Of course, there is a factor on that, but most of the people don't like to go on, using that factor to vertically scale their instance. So when they reserve it, they are literally stuck with it. So people might not agree with using the on-reserved model until and unless they are very sure, right? With sustained use discount, GCP is 21%. It does not only apply to RDS or like PaaS solutions. Based on the costing I have done for my clients, I have found out that GCP is, and this is what they claim as well, is GCP is 21% cheaper than other cloud vendors. If you are going to use SQL Server, use Azure. It's going to be cheaper, right? And then again, Aurora, can't mention this enough. It's an enterprise class solution that Amazon provides, and it's a replacement for Oracle and SQL Server. But of course, it also includes changing your application if you were going to adopt it. So what's the scoring like? So we have scored RDS 2 because of the pricing of the reserved model, and GCP 1 because of the read replica and sustained discounts, and Azure is at 0, right? So RDS has supported both the features, so we've scored RDS to 2, and GCP remains at 1, and SQL Azure has not opened its count. Right. The next thing is, okay, this sounds amazing. How do I migrate to cloud? What are different services or features that are available, and how I can migrate to cloud? Import-export is something which is supported by each and every vendor, right? So you can export your data and simply import it. That's supported by all the vendors on all the databases. Native backup and restore. RMAN backups and restore on Oracle are currently not supported on Amazon RDS Oracle, right? And you'll be pretty amazed to know is something pretty amazing is that AWS RDS support native backup restore for SQL Server, but Microsoft SQL Azure does not support a backup restore on SQL Server databases, right? So their own product does not support it at this point of time, but AWS does, right? But they are coming up with a new manage instance feature where it will be supported in the future, right? But it has been the case for more than a year for now. Migration service. And this is one of the services that I'm going to discuss is the AWS database migration service, which when they launched, Oracle was really pissed at them. Reason because they asked people that you are paying huge amount for your Oracle licenses, for your legacy systems, why don't you use this service? You pipe it, you simply extract your data from your legacy system and move it to Amazon Aurora and pay very less price for it, right? It automatically detects everything and migrates you to Aurora, right? So it's a migration service that comes from AWS, and it supports multiple sources to multiple database sources, right? Which is again debatable because it's not like supports everything, but you'll have to check the documentation on what all databases from and to it supports. So Azure also came up with their database migration service, which also supports from and to, but the to is mostly SQL Server. GCP does not currently have any migration services, right? So if you have to migrate it, you have to use either import, export, or a native backup restore. Replication is also supported by all the other vendors. I mean, you can simply, this is probably the only solution where you can have the least amount of downtime while migrating to cloud. You set up replication, you're good to go, which is also even supported by SQL Server, right? If you're doing it on AWS, if you're using replication, it does not support native SQL Server replication, by the way. You will have to use the database migration service, which is what they use to replicate the data. It's not native SQL Server replication, by the way, right? But they did want to compete with SQL with Azure, so they came up with their own solution, right? So that's the score as of now. Azure, we gave them a point because they kind of have that migration service, which is obviously good to have, right? And RDS like supports literally everything, even what. And why I did deduct a point for not being able to do a native backup restore for their own product, right? Now the backups. Backups, now if you are giving a database as a service solution, you will have to support automatic backups, right? So they do support automated backups, they do support manual backups, and each of the vendors have their own way of doing it. Either you can do an import export, or they'll take a disk snapshot, right? And all of those, all of this will be incremental, right? Interesting factor over here is that you can have the backup retention for up to either 7 days, up to a maximum of 35 days. With Google, it's only 7 days. With Azure, it's much better because you can store it up to a maximum of 10 years. Another factor with RDS is that backup, the cost is not included. You'll have to pay extra for the backups. Same applies to GCP. If you are doing the backups, the cost will be extra. If you are using SQL Azure databases, the backups cost is included. They don't charge you extra for doing the backups. But if you are going to use long-term backup retention, that's charged, right? Which is why we gave SQL Azure a score, and no one else gets anything just because of the long-term backup retention, which is good to have because if someone needs to do archival, I mean, there are different ways on how you can do long-term archivals. You can write scripts to do a manual backup literally every day and keep it like forever. But you pay extra for that, and then you have to maintain that script, and you have to maintain those backups as well. But Azure does it automatically. So that's why we decided to give them a point. Right, so now how do you restore it? Each and every one supports point-in-time restore. You can go back. Native backup and restore is supported, except SQL Azure does not support a native backup and restore from on-premise to SQL Server, right? The important point over here is that if you are going to restore your database, you cannot restore the database on top of the existing database. You'll have to restore it with a different name, and then you can rename the database and delete the old one. But Google does support restoring the database on the same database itself. AWS and Azure does not support it at this point of time. If you have replicas, if you have replication configured, you'll have to delete the secondary replica first, and then you can restore it. And then again, if you want to go beyond 7 days on GCP, it's not possible. 35 days is the limit on AWS RDS, and 10 years is the limit of restoring your database from on SQL Azure. which is why we decided to give, I think I did not give anyone, or did I give GCP a point? But these are the current standings. Right, now security. What are the different methods on how you can secure your databases on these vendors? RDS has its own identity management system. Same applies to SQL Azure and same applies to GCP. If you have ever used AWS, you will know how easy it is to configure a user and its password, right? On SQL Azure and GCP, it's not that easy. You'll have to have a domain. You have to register that domain with the vendor. Once that is registered, you either be using some other service to create accounts, and then you'll be using those accounts on the actual cloud vendor, right? With AWS RDS, using IAM is pretty easy. Encryption at rest, supported by all the other vendors, right? AES 256, transparent database encryption, it's all supported by all of these vendors. Encryption encryption with data in transit, SSL and TLS is supported for all the vendors, and GCP also supports Cloud SQL Proxy for encrypting your data in transit. All of them have auditing. You can have alerts set up on top of this. You can use their serverless architecture to take action simultaneously. So all of them supports auditing. You can use either CloudTrail, a Stackdriver, or OMS Log Analytics on Azure to be able to configure that. Network firewall. How do you allow people access over the network? They all support a firewall for that. Backup encryption is also supported. If your database is encrypted, your backups will automatically be encrypted. The only difference over here is the security assessment tool, which will scan your database and will tell you for any vulnerabilities that fails or stands out. GCP has no scanner facility at this point of time where it will recommend any security best practices or any other best practices that it will come up with, right? For example, for Trusted Advisor, if you have a firewall rule that is enabled for whole of the world, Trusted Advisor will tell you that you have a security threat. Do you want to improve it? That's supported, right? And then we have authentication and authorization, which is like having native users and roles. All of that is supported on the other vendors, right? Right, so RDS scores again, and SQL Azure also gets a point for that. Right, so now we're going to discuss about the design patterns on how to configure high availability, how to configure networking, how to configure disaster recovery scenarios on all the clouds, and how it is different on all the other vendors. Right, on AWS, you can have something called a multi-AZ deployment, which is all automatic because all you have to do is like do a simple click and it takes care of all the configuration, right? So that replication between the two data centers within a same region is synchronous, which means that you're not going to lose your data, right, during the replication. And if anything happens to one of the data centers, it automatically switches to the other database. Where you have just one endpoint to connect to, you'll have a small downtime while the failover happens, and it will simply fail over the database to the other data center, right? Azure currently does not support this. What Azure has at this point of time is that they have replicas within the same data center. So if you were to keep a replica in some other database, some other data center, it's not supported at this point of time. They do have a concept of elastic pools and a zonal configuration where it is supported, but it is also currently in preview. And I hope it is generally available pretty soon because they don't charge anything extra for that. Because GCP and AWS charges extra for the other instance that you're going to be deploying on the other data center, but Azure does not charge anything for zonal configuration. So that will be like having 3 replicas without paying anything extra. But you won't be able to manage it. Azure completely manages it behind the scenes, right? Then GCP, same as AWS, it supports multi-regional capability, multi-AZ capability, where you can have synchronous replication, high availability, one endpoint fails over, and your database gets up and running in like literally no time with little bit of downtime, of course. Right. Only thing to mention over here is that the read replica, the high availability instance of GCP can also be used as a read replica, which is something that no other vendor currently supports. Which is pretty amazing because you can have a high availability replica and you can also use it for reads. Right, which is why the current standings look like this. We decided to give GCP a point and also AWS a point because Azure does not support it at this point of time, but RDS does. Now, scalability. How do you scale your databases? Is with the read replicas. Now, of course, you don't need it with GCP because the high availability instance is also supported. But if you want, you can have replicas, more read replicas. You can have read replicas within the same region. You can have replicas within another region, which can be used as a DR node as well. You can simply cut over and promote it and point the application to the another region in case of a disaster. They also support something called an external replica. So if you want to have another replica, probably in another cloud vendor or maybe on-premise, that is also supported at this point of time. Right? And it's pretty amazing that Azure also supports it. It has lots and lots of limitations, but it is supported with a data sync functionality. It was pretty difficult to implement when we implemented for one of our clients, but after lots of tweaking and, basically, you need to have primary key on all the tables. If that's there, it's possible. Right, so you'll pay extra, first of all, and regional charges and the data center transfer costs are also applicable in this scenario. If you have a failover, which I've already discussed, if you have a region down, all the data centers in one of the regions are down, you can promote the regional replica and make it as master and connect all the applications to that particular database. The replication will be asynchronous, right? A mention for Azure over here is that in case of regional replicas, where you are using the regional replica for disaster recovery, Azure does it with the concept of geo-replication, and they also have something called failover groups, where they automatically detects the failure and fails over the database to another region. So they do support that, which is not supported by AWS or GCP, at least at this point of time. So the current standings are something like this: RDS 6, GCP, Cloud SQL 3, and SQL Azure at 4. Right, so networking. Something important to look at over here is that both these vendors, when you deploy a DBaaS service, it's public. You cannot have it on a private network. It's not possible, at least at this point of time. Only AWS support having a DBaaS solution deployed on a private network. So you can have one network where you can have your instances. It also has a firewall and also something called network access control list, which is a firewall at subnet level, which provides you extra level of security when it comes to networking, right? So only AWS supports that. Otherwise, all the other vendors, you'll be making a public connection. Even if you are in the cloud, even if your VM instance is connecting to DBaaS on the cloud, it's still a public connection, right? Which is why we decided to score RDS another point. Now, the 3-tier architecture. You can have like read contention or write contention. How do you solve it on these vendors? How will you be able to solve it on the 3-tier architecture, right? So, this is a highly available, like literally never going down architecture that I came up with. So you can have auto scaling, you can have like all the stuff in there. But the important things for dealing with write contention and read contention over here is that if you have read contention, you can have memcached in front of your databases and you can cache your data. If you have write contention, what you can do is you can push all of your data into a queue and have crawlers write that to a RDS database, right? So that service is SQS. and Memcached, they are all native service. They're both native service and are supported within AWS. Azure also same concept for dealing with read and write contention. You can have a cache implemented in front of your databases, and you can have the app servers read from the cache itself, right? And of course, maintaining the cache, it's difficult, but it's there, and you can use it. And I've seen people being able to implement it, properly, so it's possible. Then again, storage queues for dealing with write contention. GCP does not have a native service for having caching mechanism. So you'll have to deploy a Kubernetes engine, right? And you have to deploy Memcached containers on top of that, right? But Cloud PubSub is there, which can be used for writing and dealing with write contention. So pretty much the same concepts that's being used on all the cloud vendors. Which brings us to the standings, which is 8, 4, and 5. Performance. This is a benchmark that I performed on all the vendors with same configuration and same amount of resources. And what I figured out was Cloud SQL performed much better than all the other vendors. Now, if you replace this with Aurora would have literally beaten everyone else down. But Cloud SQL was better performing than, and this is all done on MySQL, by the way. And I used a tool called MySQL Slab, which is debatable that it is probably not the best tool, but I'm not an expert on MySQL. That's what I know, and that's what I used. And these are the results that I got. Right, so which is why we decided to give GCP a point over here. And lastly, the monitoring service. Each and every vendor have its monitoring service. It can have notifications, auditing, provides free monitoring, and detailed monitoring, which is the paid monitoring. CloudWatch is what you use on RDS, OMS log analytics on SQL Azure, and Stackdriver on GCP Cloud SQL. And all of these vendors, all of their monitoring tools supports literally everything, and you can have any kind of monitoring that you want to. The final score is 966. So RDS wins. RDS clearly wins. AWS RDS is clearly a winner when it comes to having RDBMS, DBaaS on the cloud, right? I'll leave you with a thought. This is a thought that I came up with after talking to a lot of clients. Every client that I talk to, they say that they are using cloud, which means everyone is using cloud. But only 10% of the people are actually properly leveraging the cloud. Running a VM is not working on the cloud, right? Because that does not make sense. If you have any questions, you can reach out to me, and thank you for bearing up with me. If you have any questions, please let me know.